Welcome to our first lab on the skeletal system. Today we are doing Chapter 9. Now the primary focus of Chapter 9 is the skull and the cranial bones in it. But before we get to that, we've got to do some basic things about bone, like some general stuff. And we're starting by noticing that there are four categories of bone. Okay, there are long bones. So long bones are defined by the fact that they have a bigger length than they do width. Their length is going to far outweigh their width. And then inside them, they have this cavity for bone marrow. So over here, we've got a good number of long bones. These aren't all long bones here, but we do have a lot of long bones here. This is a forearm bone right there. It's called your ulna. It's a long bone. There's another long bone called the radius. The bones in your hand, which are called the metacarpals, those are long bones. These bones in your fingers, which are called your phalanges, even the little ones at the end, are long bones. You are going to find long bones in your limbs. So if we draw you, I'm going to draw you right now. Dun, 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 there you are. Give you some eyes, a nose, give you a big smile because you're having fun doing anatomy. So when we are looking at long bones, invariably we are looking at the four limbs, okay? All your limb bones are long bones with a few exceptions. Your wrist bones are in your limbs, but they're not long bones. These are wrist bones right here. These are called your carpals. You can tell they don't have that same shape, that cylindrical shape. So they're not long bones. Similar bones in your ankles called the tarsals are also not long bones. And your kneecaps, your patellae, they're exceptions as well. But everything else in your limbs is going to be a long bone. And long bones, greater length and width, plus they have a marrow cavity. Okay. That's one category. Category number two, short bones. Short bones are roughly shaped like a cube. Roughly shaped like a cube. And emphasis on the word rough right there. These guys right here, these are all short bones. These are carpals. They're all short bones. The equivalent bones in the ankles, the tarsals, are also short bones. You have, on each side, you're going to have 8 carpals, you're going to have 7 tarsals, and that's all your short bones. So you have a total of 30 short bones. Can you figure out how many long bones you have in your body? Can you count that and figure that out? Be a good thing to know. Okay. Next up, we got flat bones. I forgot an S. I can't believe I forgot an S. I'm going to add an S right there. Flat bones. They're generally thin and curved. They're generally flattish. Your sternum, so think about the middle of your chest, your sternum. Your ribs are flat bones. Your scapulae. This is a scapula right here. Upper backbone. Your scapulae is the plural. They're flat bones. A bunch of your skull bones are flat bones as well. We'll meet some of them today. So 3 categories so far, long, short, and flat. Now, some bones do not neatly fit into those 3 categories. And so we group them together as the weird ones. They're the irregular bones. Your vertebrae in your back, your jawbone, your mandible, in other words. And also your sphenoid bone, which is this very central bone in your skull. Look at this beautiful looking thing right there. That's an irregular bone. Okay, these are our basic categories. Now what we are going to do is go over a little bit more intro stuff. We've got some more intro stuff to do, and then we'll get into the skull. So next bit of information is our skeletal division. Now, when we think about the skeletal system, you may think about, okay, there's 206 bones, 206 named bones. And of those 206 bones, we chunk them into two big groups. First of all, we have your axial skeleton. This is your skull, your sternum, all your ribs, etc., 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 and your whole vertebral column bones. So those are your axial skeleton, okay? Your appendicular skeleton is going to be your limbs. So we got all the limb bones here, all the limb bones. But then also your girdles. Your girdles are the structures that attach the limbs to the axial skeleton. So we've got our hip bones here as part of our pelvic girdle. That's appendicular. We have a pectoral girdle. So we got scapula and clavicle right there. That's pectoral girdle. So girdles plus limbs, appendicular. Everything else, axial. To me, that is an easy way to do it. Girdles and limbs, appendicular. All right, everything else, axial. Okay, now where would you find your long bones? Would they be axial or appendicular? Think about it, then shout out the answer. What'd you say? Appendicular, right? Long bones are appendicular because long bones are in the limbs, and we know limbs are appendicular. All right, let's talk about a long bone. This is a basic looking long bone. This is a femur. It's going to have a cavity for marrow. You can see another name for that cavity here. It is called the medullary cavity. It is definitely longer than it is wide, very much so. Now, when we look at a long bone, we're going to pay attention to the fact that it has this shaft here. The shaft of the long bone is called the diaphysis. Then there are two ends. Each end is usually a little bit more rounder, a little bit more bulgy, and each end is called an epiphysis. So we are going to have a diaphysis and two epiphyses. To make epiphysis plural, you just change that last I to an E. So a long bone will have a diaphysis and two epiphyses. We can see some other things here. We can see that there is spongy bone in that epiphysis. We met spongy bone, I think. Yes, we did a little bit in the connective tissue lab. On the epiphysis, we're going to find articular cartilage. It is hyaline cartilage. We met hyaline cartilage back in connective tissue lab. And the word articular means of a joint. So you have cartilage, which we know is squishier and more flexible than bone, at the joint surface. And that makes total sense. All right, we're going to look in a little more detail at some of these parts. So let's go ahead and do that. All right, this is a beautiful frontal section of the femur. We have the distal epiphysis. So does that mean it's farther from the trunk or closer to the trunk? Distal, farther, right? So we have a distal epiphysis. We can see there is compact bone on the outside. Compact bone on the outside, pretty thin. It's kind of worn away with, as this bone has been handled in a lab. But compact bone on the outside, and then spongy bone on the interior. And in this spongy bone, we notice two things. We notice a lot of spaces, little gaps in here. Plus, we also notice these very thin bits of bone. These very thin bits of bone, these thin bits of bone are called trabeculae. Which I think if you go to the root of the word, it's like a little connection. It's like a little beam. There's a Spanish word that's kind of similar too. Anyway, this is an epiphysis. A shell of compact bone, and then an interior with spongy bone, lots of trabeculae, and we've got space in there as well. Now, what is that space for? That space is going to be for what? The space in there is going to be for marrow. And as we'll talk about in lecture, you have two types of marrow. You got yellow marrow, which is for fat storage, and red marrow, which is for blood cell production. Okay, fantastic. Here we've gone in and taken a close-up look at the diaphysis, the shaft of the femur. The pointer here is in that medullary cavity. I do see compact bone on the outside here, and I see some bits of spongy bone in here. There probably originally was more spongy bone, but just as people handled this bone in the lab, it gets worn away. Now, this marrow cavity or medullary cavity, the word medulla often implies an interior to something. So medullary means like inside, kind of. And in here we would also find marrow. Like I just mentioned, there are two colors of marrow. There is yellow marrow for energy storage because yellow marrow is made out of fat. In other words, adipose tissue, adipocytes. There can also be red bone marrow. Red bone marrow is for blood cell production. Now, I know you are going to totally agree with me here. Blood cell production, that's 3 words. It would be easier if we just had one word for that. So our one word for blood cell production is hematopoiesis. That O-I-E makes a wee sound, okay? Hematopoiesis. Hemato means blood, poiesis means making. So red bone marrow is all about blood making. Now, this is a long bone here. If you are an adult, you have yellow bone marrow in your long bones, in your medullary cavities. If you are a child, you are going to have red bone marrow. As the kid grows up and older, the ratio of red to yellow is going to change until you're pretty much all yellow as an adult. All right, fantastic. Still on our introductory material here, we're looking at another view of an epiphysis here, another distal epiphysis. The pointer there is on some spongy bone. We are going to see trabeculae here. We are going to see spaces as well. Again, the spaces, depends on if you're a kid or a grown-up. Kids are going to have yellow bone marrow in these spaces in this distal epiphysis. I'm sorry, did I say that backwards? Yeah, I bet some of you knows that. Kids are going to have red bone marrow. Adults are going to have yellow bone marrow here, okay? When you're a grown-up, let's draw a grown-up really quick, just because I'm a fantastic artist and I love to draw. I should really teach art. Don't you think? Let me know if you agree. If you think I should be an art instructor. Because this stick figure is just ridiculous. Isn't he? Or she? I don't know. Anyway, when we think about long bones, if you're an adult, you have yellow bone marrow everywhere in your long bones except at the very proximal parts of your... You know what? I should do it in red. Oh, I got a great idea. Bear with me here. All right, I'm going to redraw this dude's head and body. And then I'm going to give him a little bit of an arm here, a little bit of an arm, a little bit of a leg, a little bit of a leg, and then I'm going to give him some more. I hope you're as excited about this idea as I am. So I think it's an amazing idea. There he is right there. All right, so... You know what? I should redo this too. I should redo this whole video, but I'm already like 14 minutes in, so I can't do that. I need to redraw this guy. Bear with me. So when you are an adult, okay? There you are. When you are an adult, you are going to have red bone marrow in the places that I am drawing red. I will get this. I appreciate your patience with me, guys. I appreciate your patience with me. There we go. This is what I wanted to do. Here it is. finally, we're getting them to give this guy some big arms, some big legs. Okay, he's got interesting proportions. All right, finally, this is basically like the distribution of red and yellow bone marrow. So when you are an adult, you've got red bone marrow in your axial skeleton, okay, plus in your girdles and in your proximal arms and proximal legs, okay? Then there's yellow bone marrow for the rest. Finally, this took way too long. Way too long. Do me a favor. Draw me your own version of this dude with the correct colors. Take a picture of it, send it to me. That is going to be a brand new extra credit project. That's for me wasting all that time. Okay, so do that for me. And I will move on to the next slide, if I can even do that. All right. We're still looking at that epiphysis, and what I want you to notice, there is something interesting here. There is a line, okay? I'm going to draw on this line. See if you can kind of like follow along with it right there. I'm going to draw on this line right here, all right? In your epiphysis, and I'm going to clear that, and do you see it? Do you see it? It's right there. That's called the epiphyseal line. It is found in adult bones. It is a remnant of where we had a plate of cartilage. So when you're a kid, you have a plate of cartilage. It's called the epiphyseal plate. It is a growth plate, if you've ever heard that term. And it is where long bones, like the name implies, grow during childhood. So we have that epiphyseal epiphyseal line right there, which used to be an epiphyseal plate. Okay, fantastic. Now bear with me for a second here. I want to jump backwards. I'm going to go backwards for a moment. Can you see the epiphyseal line here? Because this is an adult bone, and there is an epiphyseal line. It's not perfect, but there is a nice chunk of it that I can see right here. I can definitely see this chunk right here. Dun, 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 dun. And it kind of goes like that. And I can see it's kind of going like that as well. So there is that epiphyseal line. See if you can still see it. Beautiful. And that's something adults have. When you are a kid, you have an epiphyseal plate. And it is a chunk of cartilage. That is where growth occurs. When you're done growing, that cartilage chunk has disappeared and all that's left is a bit of bone. All right. Done with basics of long bone structure. Fantastic. I'm excited about that. What I'm looking at here is a flat bone structure. This is a skull up here. This bone in the front of your skull is the frontal bone. It is a classic flat bone. And what we're seeing here in this expanded view is basic flat bone architecture. So a flat bone is a sandwich, all right? And it's got bread. The bread is on both sides here, like a normal sandwich. And the bread is made out of compact bone. And in the interior, the meat, the cheese, the tomato, the pickle, all the delicious parts of a sandwich is made of spongy bone. So this interior, the sandwichy goodness in here, is spongy bone. And there's actually a special name for this spongy bone portion. It is called the diploa. The diploa. I think I forgot to put the umlaut on the E right there. Diploa. There we go. I knew a teacher who would take points off if you wrote the word diploa and you didn't put the two dots, the umlaut, over it. She would mark you like half off. Luckily, I am not that teacher. So, good news. Good news for everybody. Okay? The word diploa basically means like doubled, like a fold or something. And because you can see, it's kind of like we have a top part and a bottom part, and then they're almost like mirror images of one another. Anyhow, the spongy bone here has trabeculae, beautiful, beautiful trabeculae, and it would have red bone marrow in there. So there would be red bone marrow in there. The red bone marrow, of course, is for hematopoiesis, which is blood cell making. All right, my friends, that is excellent and fantastic, because we are done our intro material and we now get to look at this beautiful skull. We're going to look at this beautiful skull. And we are doing the cranial bones today, okay? So cranial bones are going to form your what? Your cranium. Who remembers what cavity we have in the cranium? Shout it out. In the cranium, we have a cranial cavity. And so these bones of the cranium are all going to contribute to the cranial cavity. Now, I want to start naming some of these bones. We're going to name them all, and then we're going to go through them one at a time, okay? So let's do that. Let's start with one we already named right in the front here. We've got the frontal bone. So in the front, we got the frontal bone. You can also see it in my side view here. I'm going to throw an F on it right there. So in the front, we have the frontal bone. So that's one. Now, behind the frontal bone, and very visible in this lateral view, is a bone called the parietal bone. So I see one of the parietals. I see a right parietal there. And I can see a smidge of parietal here and a smidge of parietal here. So that's three. We got three bones in the cranium right now. And let's keep on going. So also visible in this side view, really, really nicely visible in the side view, is this bone right here. It is called the temporal bone. By the way, let me backtrack for a second. Frontal, so named because it's in the front. Parietal means wall, and so much of the wall of your cranial cavity is made by the parietal bone. Temporal, if you think about the word temporal, what does it remind you of? What other words? Maybe like temporary, right? And so there's an idea of the passage of time here. And think about where like gray hair might start to appear, right here at the temples. Okay, this is the temporal bone. Beautiful looking bone right there. We can see the temporal bone here. We can see the temporal bone here as well. So that is two more bones there. So now we are up to what? We had 2, 4, 5. We got 5 total. Now in the back, we've got a bone here called the occipital bone, which literally means at the back of the head. Occipital. I did some terrible handwriting right there. O-C-C-I-P-I-T-A-L. Occipital. And I can see that the back there. I don't see it from the front view. So, got 6 bones so far. 2 more to go. Now, there is a bone called the sphenoid bone. And I'm gonna do an arrow for that one. We can see the sphenoid bone right there. Bum, bum, bum. I'm going to write the word sphenoid right here. So that's the sphenoid bone. It's kind of right, it's like right in the center there. It's a very important bone. There's just one sphenoid. So it's by itself. So that's 7. I can also see the sphenoid, the purple right here in the back of the orbit. That's sphenoid as well. Last but not least is a bone called the ethmoid bone. And so I can see my ethmoid bone as well. You can definitely see that. It's putting an arrow on it. It's right here. You can see it in the orbit there. It says the ethmoid bone. I'm going to spell that vertically, which is not a good way to do it. But you forgive me. Ethmoid. And I can also see the ethmoid bone down here. Put some yellow dots. I'm putting some yellow dots on the ethmoid bone in the nasal cavity. So it's in both the orbital and the nasal cavity, as well as the cranial cavity, because all 8 of these bones are going to form the cranial cavity. So we've named all 8. We now are going to, in a moment, start looking at all 8. Okay? Let's do that. Let's get to that. Oh, lest I forget, we got a top view here. Let's look at them. Look at these guys from the top view. So there's my frontal bone from the top view right there. Here are my 2 parietal bones. I can see a little tidbit of temporal right here, right here. I can see an occipital bone back here as well. Now, I also want you to pay attention to the joints between these bones. Look at the zigzaggedness of the joint. This kind of joint is called a suture because someone thought it looked like a suture. And all the back and forthness of this right here, all the back and forthness gives you a tremendous amount of surface area and interlocking. And that is going to give you a really strong attachment between bones. Almost all your skeletal joints in your skull, almost all of your joints in your skull are going to be sutures. Think about it for a second. What's the only skull bone that you can move? The mandible, right? The other ones you can't move. So the other ones are locked in place. They're locked in place because we have these really strong interlocking joints called sutures. We'll name some of the sutures in a moment. Let's finish going through the bones. Let's see, we're done on the left side here. On this right side here, I can still see my frontal bone right there. Inside the parietal, occipital, temporal. And now I can see my sphenoid bone a little bit better. This purple guy here. I can see my ethmoid bone as well. So pretty cool. Okay, let's talk about some of these sutures. This suture right here, this guy between the frontal and the two parietals, that suture right there, oh, it has a great name. It is called the coronal suture. Do you remember that word? Remember, the coronal was a type of cut that would slice you into a front and back portion. So this coronal suture is on that coronal plane. Fantastic. We can also see this guy right here between the two parietal bones, this dude. And this suture, I didn't do justice to all the jaggedness of it. This suture is appropriately called, you're probably guessing it right now as I make this G right here. What's the answer? What's the name of this suture? You should have it right now. If I put an I and a pair of T's and an L, you should totally have it. It is the sagittal suture. It is the sagittal suture. Sagittal, because again, think about cuts. A sagittal cut would cut us into left and right hand portions. Okay. So it has two sutures. There is another suture visible in this top view. It is this guy right here. Bum, 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 bum. And that suture is called the lambdoidal suture. That's my favorite one. It's like the name. The lambdoidal suture. And I'll explain that name for you in a moment or two, okay? Now, I bet you're wondering, actually, you're probably like, hey, what are these green things? And these are actually extra little bones. Everybody has some sutural bones. At least I think everybody does. I don't know if anybody doesn't have any. Some sutural bones. You may have like 7, you may have like 3. It varies. But those are little bones that are formed within the sutures. So if you ever see those, that's what they are. All right, let's jump over here. This suture right here is between frontal and parietal, so it is coronal. This guy back here, right here, is going to be our occipital one. And I can also see this guy. I got another one that I can see here. This guy is between parietal and temporal. And this one is called the squamous suture. Hey, we've met that word before, haven't we? Squamous meant really flat or thin, right? This will be important later. We'll come back to this, okay? All right. So we got some sutures here. Good news, we are not naming every suture in the skull, okay? We're going to do these guys, and plus we're going to do one more suture later. All right, let me jump back for a second. I just want to show you the outside view of those sutures that we just named. I'll ask you, what is this suture right here? It is what? Tell me. Occipital. All right, what is this one right here? This one is, I'll give you the initial if you need it. It is squamous. This guy right here, give you the initial if you need it, but you probably already got it. It is, if I can make that letter, there we go. It is coronal. Okay, excellent. We still got to do some bones, right? I know, there's a lot to do today. All right, what we are going to do is zoom in on the frontal bone and start looking at its parts. This is the frontal bone, like right above the orbit, okay? Think about where your eyebrow is. So touch your eyebrow, and find that ridge of bone kind of right underneath your eyebrow. That ridge of bone right underneath the eyebrow is part of your frontal bone. It is called the supraorbital, above the eye, supraorbital, the supraorbital margin of the frontal bone. It helps form the superior orbit, and it structurally reinforces your face. So that's one part of the frontal bone we got to know. If we slice our skull in half, so here's the top of your nose right here. So find the top of your nose, like find your nasal bones. Find the part where glasses would sit. If you're wearing some regular glasses, sunglasses, find that part. And then walk up a bit until you're like in between your eyebrows, more or less, in your forehead. Right there, you have a cavity in your frontal bone. That cavity is called the frontal sinus. Now, I bet you've had a headache right there. So you might have had a sinus headache right there. Sinuses are cavities inside bones, and their primary job, is to make mucus. They also make your skull a little bit lighter, which is nice for your neck. Makes life easy for your neck. But their primary job is to make mucus. The thing is, you breathe a lot. All right? You breathe in a lot of air. Whenever you breathe in air, you've got to warm it up, humidify it, and filter it. And you do that with mucus, starting with the mucus in your nose. But your nose can't make enough mucus on its own, so there are mucus-making factories in your skull, and it's these cavities. These cavities are lined by a mucus-producing epithelium. Think goblet cells here, okay? And the mucus drains from the sinuses into your nasal cavity. Sometimes when you're sick, the epithelium of your sinuses can get inflamed, the passageways can get blocked, pressure can build up. Boom, sinus headache. All right, this is good stuff. So we're doing our frontal bone here. We're knocking out some of the parts of it. We just did the supraorbital margin. We just did the frontal sinus. And now we're going to take a look at that coronal suture. So here is the frontal bone here. Here are my two parietal bones. So frontal bone is here. Parietal bone is here and here. That was a P up here. So this guy right here, where that pointer is, that is the coronal suture. Beautiful interdigitation in that suture. I love it. All right. If we look here, we can see a real skull. Let's just look at that frontal bone again in the real skull. Beautiful frontal bone right there. Let me ask you some questions real quick. What is this part right here? I put a red dot on it. Put a red dot on it right there. Tell me what that is. It's the supraorbital margin. All right, what would I find deep right here? I would find what? The frontal sinus. And what does that frontal sinus do? Makes mucus. All right, one last thing. What is this joint that I can see right here? It's the last part of your quiz here. That joint is the coronal suture. And what kind of joint is a suture? Is it a movable or immovable joint? Immovable is your correct answer. Yes. All right. See it again. We saw this picture again. Frontal bone, coronal suture, frontal bone, coronal suture, frontal sinus. All right. And now we see our two parietal bones. They are rather uninteresting. It's like the sutures are the most interesting things about the parietal bones. Here we have the sagittal suture, bum, 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 between the two parietal bones. We talked about the coronal suture earlier. We see it right there. If I look back at the back, if I look at the back, there we go, of the skull, I can see my two parietal bones here. Here's a parietal right here, beautiful sagittal suture right there. This is my occipital bone right there. And this guy right here, this dude, is the lambdoidal suture. Now, I know you guys probably took Greek, like the language, as a language course, and you learn the Greek alphabet. In the Greek alphabet, there is a letter called lambda, which looks like this kind of. It is like an inverted V with some feet. And somebody thought that this occipital bone, not this occipital bone, this suture of the occipital bone here looked like an inverted V. And so they said, well, it looks like a lambda. It's lambdoidal. Now I do see a sutural bone right here. This 2A right here is a sutural bone, one big sutural bone. You could have one big one, you could have a couple little ones. It depends. Okay, let's change our view here. If we drop down a bit on that occipital bone, on the back of the occipital bone there is a bump. So it is right here. This bump, it's on the outside of the occipital bone and it's a bump. All right, we got to translate that into a more scientific sounding set of terms. We're not going to say outside back of the head bone bump, right? We're going to say external, because it's on the outside. Occipital, because it's the bone in the back of your head. Protuberance, because it's a sticky out bump. Now, general point of fact here. When you have sticky out pieces on a bone, they're generally going to stick out for ligaments and tendons to attach to. And this is exactly what happens here. This external occipital protuberance is a place where ligaments from your cervical vertebrae and also muscles in the back of your neck can grab on. If you feel the back of your skull, I bet you can find this external occipital protuberance. I can find mine right now. It's pretty easy. If you have short hair, it's even easier. So find it on somebody. Pause the video, go find somebody's external occipital protuberance. Okay. Excellent. Let's keep going. Let's look at an inferior view of our skull. Look at that purple occipital bone right there. Look at that beautiful purple occipital bone. Dun, dun, dun. This whole thing is the occipital bone right there. And what I want you to notice, of course, is the big hole in it. You know the name of that big hole. You met that. That big hole is called the foramen magnum. It is where your brain attaches to your spinal cord. That big hole is a great landmark. Fantastic landmark. Here, I've got it pointed out on the skull model here. Foramen magnum right there. The big hole, literally. Foramen means hole, magnum means big. Now, I switched it to the inside of the skull. We can see the foramen magnum from the inside as well. So we're looking at the inside of the cranial cavity here. If we jump to the side of the foramen magnum, there is this bump on each side. This bump on each side is called an occipital condyle. The word condyle means knuckle. So if you make a fist right now and look at your knuckles, somebody thought these bumps were kind of knuckle-like. Now, this is going to be where your occipital bone sits on your first vertebra. Your first vertebra is called your first cervical vertebra because it's in your neck. It's also known as the atlas. Do you guys remember when you took Greek mythology? Remember that? You took Greek mythology and, oh my God, this is awful. I need to undo all that drawing right there. I'm just going to draw a stick figure. Just doing a stick figure. Got to go back to the basics sometimes, you know. So in Greek mythology, there was this character called Atlas. And what was he doing? He was holding up the heavens. He was holding up the sky. He was bigger and more muscular than my stick figure here. So because your first cervical vertebra holds up your head, someone made the classical analogy to Atlas from mythology. Anyway, the joint here, this joint between this occipital condyle on each side and the first cervical vertebra is going to allow your head to make a yes motion. When you nod your head, yes. When I ask you, like, are you going to do great on this upcoming lab exam, you're going to use this joint. You're going to nod your head and say, yes, yes, I will. Okay. Here we see a real skull. What is this bump back here? Bump, bump, bump. That bump right there. External occipital protuberance. What is this hole right here? This hole right here is what? Is the foramen magnum. What is this knuckle-like protrusion? Here and here. Those are your occipital condyles. Okay. We got the frontal bone done. We got the occipital bone done. We got the parietal bones done. We actually only have, what, 3 more to do. Temporal, sphenoid, and ethmoid. So we're going to do the temporal bone right now. Look at that beautiful temporal bone. It is on the lateral skull very nicely. You see it so gorgeously. Dum-da-dum. I'm going to trace the whole thing. There it is. There's a temporal bone. All right, we're going to learn some parts of it. And this hole is really important, so pay attention to that hole right there, okay? All right. First up, let's talk about the suture. The temporal bone meets the parietal bone at this squamous suture. Okay, so parietal's up here, temporal's down here. That suture between them is called the squamous suture. Now, I know you know that squamous means flat. So here's the deal. This part of the temporal bone, right, basically this whole like sticky up part right here is called the squamous part. It is super flat. It is really, really skinny. If you were to take a temporal bone and like rotate it so you could turn it and see that flatness, you would be amazed how like eggshell thin this thing can be. So this part is squamous because it's flat. And so the suture next to it is called the squamous suture. Beautiful. Okay. Let's keep on going. There's that hole I talked about a moment ago. This is your ear hole. Your temporal bone has your ear hole. Now we cannot use the word ear hole, can we? Instead we say external because we're looking at the outside. Acoustic because we know it's going to have to do with hearing. Meatus, which is a word for tube. So this guy goes through the temporal bone. It is going to have your hearing machinery, your auditory structures. So if you remember, you had bones in your middle ear, your malleus, your incus, and your stapes. You're going to find them in that passageway. You also have inner ear machinery, nervous machinery that is going to be involved in hearing as well. So this is an important tube. It is also a magnificent landmark. Okay. If I find that tube again, so I find that external acoustic meatus right there, and I go down, like straight down from it. I find a sticky out projection right here. Find this awesome sticky out projection. This awesome sticky out projection is called the styloid process. What do you use on your iPad? You use a stylus. What's the French word for pen? Is it pen? Pencil? Un stylo? Anyway, stylus means column. It is this thing that projects downward. It is going to anchor tongue and neck muscles. Remember, sticky out things are often for ligaments and tendons. And of course, tendons attached to muscles. By the way, sticky out things are often called processes, especially if they're kind of skinny. Okay? Or if they really stick out. This rule won't always work, but this is a styloid process. Okay, let's find some more temporal bone stuff. All right, let's orient. There's our ear hole. Straight down from our ear hole, we had our styloid process. If we go a little bit to the back, there is a pretty big bump called the mastoid process. If you go like kind of behind your earlobe, you can find this bump. You can feel it. It's very palpable. Now, some big, strong neck muscles grab onto it, which is why this bump is big, because strong muscles anchor on it, and when strong muscles pull on bone, that bone responds by growing and getting thicker itself. Okay, so we definitely got some things on this temporal bone. I jumped to a bottom view. I kind of hate the bottom view sometimes because it's tougher to figure things out in this bottom view, but I still want to point stuff out to you. Here's our styloid process right here. Okay, here's our mastoid process right there. There's our external acoustic meatus as well. All right, now here's the skull model, which I think is actually kind of prettier than that picture, to be honest with you. So there's that mastoid process. Again, check out the acoustic meatus right there. So if you think about it, here's the foramen magnum. Jump out of the foramen magnum, boom, you're on the occipital condyle. Take a big jump in that same path, and you hit that mastoid process. So in that line, occipital condyle, you can kind of line those guys up. Okay? All right. What else do I see? I see an indentation. An indentation on a bone is often called a fossa. So this indentation here, and there's actually a pad of fibrocartilage, really strong cartilage in it. This indentation here is called the mandibular fossa because it is the dent, the depression where the mandible is going to join and form a joint with the temporal bone. That is, the movable joint you have on each side of your skull, which lets your jawbone move up and down. That joint there is called the temporomandibular joint. All right. Beautiful. Guys, we're almost done the temporal bone. All right. So the external acoustic meatus is back here. And coming out towards the front of the temporal bone is this long, sticky out process. It is called the zygomatic process because it goes towards this bone called the zygomatic bone. So the zygomatic process of the temporal bone is this guy right here. This whole thing right here. And then this little chunk over here is the temporal process of the zygomatic bone. So I know you're going to hate this, but we have a zygomatic process of the temporal bone uniting with a temporal process of a zygomatic bone. All right. Excellent. You can feel this, by the way. Think about like on the side of your face, cheekbone area right there. You can totally feel this thing. Okay. If we flip the skull and we take a look at the inside, We can see a ridge. Whoops, see, went too fast. I hate it when I do that. We can see a ridge right here. This bony ridge, and I got it on both sides. This bony ridge is called the petrus part of the temporal bone. So we have a squamous part, that wall on the outside. This bony ridge on the inside, in the cavity here, is the petrus part. Petrus means like a rock. Someone thought it looked bumpy and hard like a rock. If I look on the model here, I see my petrus part of my temporal bone. The external acoustic meatus, that ear passageway, actually goes through it. So this is a weird situation. I have bones inside this bone. There are 3 bones inside this bone. The 3 bones are the auditory ossicles. Auditory because they're involved in hearing. Ossicles because they're little. They are the malleus, the incus, and the stapes. And, wow, I think we just named everything on that temporal bone. That was kind of a lot, wasn't it? If we look at the temporal bone from the front, I see a little bit of the squamous part here and here. I see my squamous part here. All right, what is this suture right here? Shout it out. Squamous. What is this hole right here? It's the ear hole on the outside, right? So, external acoustic meatus. I go straight down. This guy here is my styloid process. I go back for the big bump. That dude right there is the mastoid process. And the long sticky out one right here is the zygomatic process. And of course, make sure you have an idea of what these processes are doing. If we look right here, we're about to do the sphenoid bone. Let me back up for a second here. We are moving on to the sphenoid bone. I thought I had another real skull picture for a second. Sphenoid bone time, okay? Remember when we were talking earlier, a long time ago, I know, we could see the sphenoid bone right here and also in the orbit, okay? So let's start by looking at this side view sphenoid bone. We're going to look at this part right here, and then we're going to look at some other parts too, okay? All right. So if we zoom in, this is the sphenoid bone right here. So check it out, okay? If we find the temporal bone, all right, here's the zygomatic process of the temporal bone. The ear hole is back here. Here's the squamous part of the temporal bone. If we're walking on the squamous part, and we go forward, we get to this right here. This piece is part of your sphenoid bone. This guy is part of something called your greater wing of your sphenoid bone. That is your greater wing of your sphenoid bone, forming part of your lateral cranial wall here. Okay, so we can see the sphenoid bone on that outside part right there. If we go into the orbit, we're seeing the sphenoid bone again. So look at this. This is the eye socket right here. This is the eye socket. Okay. Up top here, we had that supraorbital margin of the frontal bone. All right. I'm just going to say SMF right there. If we look in here, this big chunk of bone in the back of your orbit is going to be sphenoid. This part here is your greater wing of your sphenoid bone right here. Forms a big part of the back of the orbit. Okay. Now, if I look at this guy right here, this is the interior view, okay? And in this interior view, guess what I can still... why did I do that? Why did I advance that slide? I meant to draw. There it is. This is the greater wing of the sphenoid right here. And right here. Beautiful. Okay, let's look at some more views here. Here's the model. Here's that greater wing right there. Let's label it. Here's that greater wing. Bum, bum, bum. Greater wing is in front of the temporal bone right here. It is behind the frontal bone right here. Frontal bone has this beautiful shelf in it right here. I don't know if I mentioned that earlier, but I'm mentioning it now. There's the shelf of the frontal bone right there. So there is your greater wing right here. I know I make you guys draw stuff. I'm not going to go crazy trying to make you draw like the entire interior of the skull. But if you think that you learn by doing stuff like that, there are actually some pretty cool anatomy coloring books out there. If anybody wants me to do this, let me know. I think, because I have a PDF of these anatomy coloring books, and I think I can probably post it on Blackboard. So if you want me to do that, just give me an email and say, hey, can you post that? All right. Where was I? Greater wing. Fantastic. It's in the cranial cavity here. If you're in the cranial cavity, you are supporting the brain. All right. So, what have we just been talking about? We've been talking about the sphenoid bone. We've been talking about the greater wing. If there is a greater wing, it stands to reason that there is going to be something called the lesser wing. So what I'm seeing here, what I'm outlining in blue, is the lesser wing of the sphenoid bone. The lesser wing of the sphenoid bone. Also part of the floor of the cranial cavity. So the greater wing, good old greater wing, was back here and back here. And then this is the lesser wing up here. Okay, again, it's got that frontal bone in front of it. This is frontal right here. And this kind of pointy looking thing is the ethmoid bone, which we will meet shortly. Okay. Now, if we jump behind the lesser wing, so sort of in between the two halves of the two like greater wing chunks. There we go. So we got lesser wing, we got greater wing, we got greater wing. Right here, there is this saddle. It looks like a saddle. I swear, it looks like a saddle. Okay? This saddle is called the sella turcica. Sella literally means salad. Sorry, sella doesn't mean salad. Sella means saddle. There we go. I'm getting hungry. That's why I said salad. Turcica means Turkish. I don't know how many of you ride horses, but they're like Turkish saddles versus English saddles. And so someone thought this thing looked like a Turkish saddle. So sella turcica. It is going to hold an important gland called the pituitary gland, which is very important for bone growth, among other things. I love the sella turcica because it is a great landmark. Sella turcica, jump to the front, lesser wing. Jump to the sides, greater wings. Beautiful. Love landmarks. Oh, speaking of landmarks, this sella turcica right here, notice how you have these ridges. Do you remember these ridges? These ridges right here. These ridges were the petrus parts of the temporal bone. The petrus parts of the temporal bone point at the sella turcica. They're like two fingers pointing at it, which is cool. Okay. Man, we are nearing on an hour here. I really feel like this is quite possibly the longest video of the entire semester. All right, in front of that sella turcica, kind of going under the lesser wing, we're going to have a pair of passageways. There's one here, which my pointer is kind of sticking in. There's one right here as well. Each of these passageways is called an optic canal. Optic, you're thinking eyeballs already. These passageways allow the optic nerves to go from the orbit to your cranial cavity. Okay, so these are going to connect your retina in the back of your eye to your brain so you can actually interpret what you see. So optic canals. If we rotate this guy and we look in the orbit, you can see it's got some light behind it, which is beautiful. This right here is an optic canal. That's an optic canal right there. This is actually the lesser wing of the sphenoid bone right there. So the hole in the back of the eye is the optic canal. The hole in the back of the eye. All right. Let's keep on moving. All right, so still in the orbit here. I'm kind of covering up the optic canal, and I can see this is my lesser wing here. This is my greater wing here. And there is this kind of like this slash of space of light between them. This is called the superior orbital fissure. So it's a space between the lesser and the greater wing. Bunch of blood vessels and nerves are going to go through there. Because you don't just have the one nerve for your eye that takes the sensory information of sight back to your brain. You also have to have nerves going out to the musculature around your eye and in your eye. You have to have blood vessels to feed that eyeball. So they pass through this space, which is the superior orbital fissure, which separates the lesser and the greater wings. All right. We are so close to being done with this sphenoid bone. Just one more piece. We're looking at an inferior view of the skull here. And we see a lot of good stuff here, okay? We can see some teeth. Let's start with something easy. We can see some teeth. If we go to those back teeth, and then we jump from the back tooth, back molar right there, we can see a sticky out thing. That sticky out thing is really like sticking down from your skull. So we're looking at the bottom of the skull, and this thing here is sticking down. It is called a pterygoid process. Someone thought it looked like a wing, so it's called a pterygoid process. There's one over here as well, this whole thing here. Pterygoid process. Whole thing here, pterygoid process. It is going to anchor chewing muscles. So we can see some pterygoid processes there. Jump behind the teeth, we got them. Also, we can see the two holes for the back of the nose here. These are the holes in the back of your nose. So think about your nostrils as being your front nose holes. These are your back nose holes. You've certainly had mucus drip down these holes into your throat. I bet you've had some liquid milk, water, something go through these holes and up into your nose, like if you're laughing and drinking or something. Hopefully it wasn't like soda, coffee, something like that. All right, if we find those holes, next to those holes we have pterygoid processes, okay? So find those back nose holes. Back nose holes, pterygoid processes. Beautiful. All right, let me get rid of these. So we got a side view, we have a sagittal view of the skull here. I can still see my pterygoid processes right here. I can see my sella turcica right here, that little cavity. I can also see this space where I'm putting some dots. That space is the sphenoid sinus, which is a mucus production zone. Okay, sweet. With that, we are done with the sphenoid bone. Remember, we can see this. Whoops. We can see this right here. What is this? That is the greater wing of the sphenoid bone. Over here, greater wing of the sphenoid bone. Over here on the side, you guessed it, greater wing. I can also see my orbital cavity. I'm going to put a little red dot right in that orbital cavity, and that one too. I'm going to put a blue dot in my superior orbital fissure right there and right there. And another blue dot on the lesser wings. All right. Let's now do the ethmoid bone. So the ethmoid bone is going to be near the sphenoid. It is going to be visible in 3 cavities. Okay, we're going to see it in the nasal cavity. So this is ethmoid bone here, here, and here. We can also see the ethmoid bone in the orbital cavity. Kind of hard to see from the front, but if I look over here on the side, I can see the ethmoid bone on the side right there. And when I cut my skull open, I'm going to see the ethmoid bone in the cranial cavity as well. Okay, let's start looking at that model. This sort of quadrate chunk, this kind of quadrilateral that you see right here, that is the orbital plate of the ethmoid bone. Right there. It's going to form the medial wall of your orbit. It is right there. You can see, check it out, the optic canal is back there. There's a superior orbital fissure. You can see those, okay? All right. So we're done with the orbital plate of the ethmoid bone. Let's keep on going. There we go. I should have probably cleared all that drawn stuff. Let's do that. Another part of the ethmoid bone we can see is this chunk right here. This chunk right here, very vertical piece, is called the perpendicular plate. Oftentimes if you have flat surfaces on a bone, we use the word plate because the word plate means flat. This is going to come down off the main body of the ethmoid, and it is going to divide your nasal cavity into left and right halves. So the perpendicular plate of the ethmoid bone, in fact, is helping to form your nasal septum. It produces your superior nasal septum. So this is also the ethmoid bone right here. So we see it in the orbital cavity and we see it in the nasal cavity. If I slice this skull sagittally, I can really see the perpendicular plate in all its beautiful glory. This whole thing here is the perpendicular plate. That whole thing is the perpendicular plate of the ethmoid bone. All right. Fantastic. Let's take a look at my skull model again. I'm super in close on the nasal cavity, okay? So we got some front teeth down here, right? Upper jawbone here. Here is the perpendicular plate of the ethmoid bone. The whole nasal cavity is this cavity right here. There's that perpendicular plate right there. If you look on either side of it, there is a bulge. I'm going to put some red dots on that, on the bulges here, on that bulge, okay? So there is a bulge right there. That particular bulge is called the middle nasal concha. The middle nasal concha. Concha means it's like a kind of shell, like a conch shell. Someone thought it looked like this type of shell. I don't know. But this nasal concha bulges out. By bulging, you get more surface area. With more surface area, you get more mucus. With more mucus, you can do a better job filtering, warming, and humidifying the air that you breathe in. Now, I know you're thinking, you're like, hey, there's a middle one? Is there also are there other ones? Well, there is a superior one as well that also belongs to your ethmoid bone. We just don't see it in this model. We do see an inferior nasal concha, but it is its own bone. So we're going to meet it next time in the next lab video, which I swear to you will not be as long as this one. All right. Almost done, guys. If I look at, I just wanted to check something out here. I wanted to jump over here as well because we have all three conchae in this view. Superior, middle nasal conchae, superior middle nasal conchae right there. The superior and middle nasal conchae, they belong to your ethmoid bone. And then the one on the bottom here, this dude, is your inferior nasal concha. He is a bone unto himself. So we can see all three conchae here. Top two belong to the ethmoid bone. Bottom one is a bone unto itself. All right. If I backtrack, there we go. Now we're looking at that cranial view. And I just see a little chunk of ethmoid bone here. Little chunk of ethmoid bone right there. That's the only part of the ethmoid bone we can see in this top view. In the skull model here, I can still see, I can still see it. it is this chunk right here. This chunk right here is the ethmoid bone. Now there is a sticky up piece. It's right here. It's sticking up. It's very thin. It's like a shark fin coming up. It is called the crista galli of the ethmoid bone. Crista means crest. Galli means rooster, because someone thought it looked like the thing on the top of a rooster's head. It sticks up. It anchors your meninges, which are your membranes that hold your brain in place. So we got the crista galli of the ethmoid bone. If we look to the side of it, there is a flat portion. This flat portion's flattish on either side of it. So where the 58 is right there, that's the crista galli. On either side is the flat part. It is called the cribriform plate. The cribriform plate. And the word cribriform tells us that it has holes. That's what the word cribriform means. It's got holes. And if I look at this real skull here, I can actually see the holes. The holes are foramina. Foramina is the plural of foramen. So foramen is a hole. Foramina are holes. These guys are either called cribriform or olfactory foramina. They're going to perforate that cribriform plate. They let olfactory nerves, so smell nerves, go from your nasal cavity to your cranial cavity. And we can see them beautifully right there. Okay. Let's keep on going. We did this slide already. Fantastic. Oh, before we go on, check out that crista galli right there. You can totally see that crista galli. And with that, we are finally, blissfully finished with this Lab 9 video. I am super excited about that. I will see you guys next time. Take care and goodbye.